All right, welcome to the video on the back of the paper, which seems more involved, but in many ways, it's actually there's less. So on the front, there's rule after rule after rule. On the back, there really is only one rule, and the rule is you want the problems to look basically like this one. You want them to look like an integer and then an x, y, and a z. Okay, and so the basic idea is you break down the number like you did on the front, right? You just use a tree. This is the third root, right? This is the 1/3 root. So what you're doing on this problem is you're trying to look for three of the same thing. So you pull out, in this case, 2 times 16, 2, 8, 2, 4, you pull out the 2. If you take the cube root of a negative, right? So if you have a negative cube root, it's always going to be a negative. If you have a negative in a square root, that would be an I. And then the first thing you do is write this as a fraction. 5/3, 4/3, 9/3. Okay, you see my answer here. 5/3, 4/3, 9/3 is 3. Okay, then once you do that, there is a second answer that emerges from turning those into mixed numbers. Because 5/3 is really 1 and a third. It's 1 and 2/3. 1 and 2/3. You can see that I did the math here. You have 1 outside, right? That's the 1 here. And then you have 2 inside, that's the 2 here, okay? So 4/3, that's 1 and a third. Remember, the third is really the cube root, and then the 3 didn't reduce, so you just leave it alone. And you just keep doing that. You do it with the fourth root. Over here, I wrote the 1/5 as the 1/5, but it's really the fifth root. Basically, you should basically say to a question like this, I don't like this. I want to write it as the fifth root, and then you're looking for 5 of something and turning things into fractions over 5. 6/5, 10/5, 10/5 is 2. The 6/5 is 1 and a fifth. Okay. So when you come down to this thing, all of a sudden now I'm asking you to add so you can figure out the difference. Well, when you add, you have to break stuff down before you keep going. So what happens here is this cube root of 8, right? The cube root of 8 is 2. So you're going to take the 2 and multiply times the 5 and get 10. And then here you have the cube root of 6, which we just learned up here. That would really be 6/3. So that's really x squared. Here, the cube root of 27 is 3. So 3 times 2 is 6. And then here you have 6/3. So you have a 2. And then you just combine like terms. I mean, this problem is now just normal. 10 minus 6 is 4, x squared. So what do you do if stuff doesn't quite break down? So here in this 54 one, you divide by 2. Then you divide by 3. Okay, and you're looking for a group of 3. So here's my group of 3. And then you have this root. So this thing right here is going to become, 1 second. All right, so that thing is going to become 3 cube root of 2. And so you're doing some of the stuff you already did on the front. That'll be 3 cube root of 2. And then to do the x's, right, that's really 3 divided by 3. So there's actually an x here. So what you're looking for when you break down these other things is the same root. So see if we get one here. When I add this together, the cube root of 8 is 2, and 2 times 8 is 16. So you don't combine that. It just sits there. The question is, when you do this part, will it combine with either? If it doesn't, you just make a list. Make a list. Okay, so what do you do when you have to multiply or divide? The first thing you need to recognize that is extremely important so that you don't get frustrated and do extra work is that on every one of these problems, for instance, notice these first two, I wrote one as a fraction and one as a root. The entire purpose of that is so that you say, no, 1/2 is really the square root. No, 1/3 is really the cube root. You want everything to be written in terms of roots. Okay, so then you multiply, that 5 is outside, so it stays outside. Then you multiply the 8 gets multiplied times the 2, and that makes -16. And then you multiply the x to the third power times the x to the fifth power. You add the exponents to get 8. And then you multiply the y to the 6 times the y. Please remember that that y actually has a 1 on it. Right? It's important to remember that. So 1 plus 6 is 7. And then you do exactly what you did on number 26, 27, and 28. Just remember that when you take the square root of a negative, that makes an I. When you take the square root of 16, that's a 4. So 4 times 5 is 20. That's how I got 20i. Then the 8 is really 8 divided by 2. Remember that a square root has a little 2 on it. So 8 divided by 2 is 4. 7 divided by 2 is 7 halves. And then you have to turn the 7 halves into a mixed number, which would be 3 and 1/2, or 3 and the square root of y. When you do the cube root, you do the same thing. 9 times 3 is 27. 5 plus 6 is 11. 2 plus 4 is 6. Then you break down the 27, the a, and the b by making fractions. And then your second answer is to turn them into mixed numbers. When you divide, right? When you divide, instead of multiplying, you subtract the exponents. But you still just divide. Like if I were to look at 625 divided by 5, that's negative 125. If I were to take 12 and divide by this, I subtract and get 10. 16 divided by 4 is really 16 minus 4. You get 12. A negative in the cube root is a negative. The cube root of 125 is 5. I would make this 10/3. I would make this 4/3, which is, I'm sorry, 12/3, which is 4. This part makes the second answer because it's really a mixed number of 3 1/3. I did the division here. All right, let's talk about solving. When you solve, the basic idea is to solve like we did last chapter. You subtract 4, you're reversing the order of operations, starting with adding and subtracting first. All right, so that's a 3, not a cube root. Here you get 6, and then you divide by 3, which will give you 2. And then the question is, how do you get rid of a square root? You get rid of a square root by squaring. Hopefully that makes logical sense. So your next step will be to square this, which will cancel, square this, which will make 4, and then you'll solve that normally after you cancel that out and make that a 4. And that's basically the idea. You can see here that I subtracted 4 and got 3. Then I cubed both sides and got 27, and then you solve that by reversing the order of operations. When you get to number 40, there's nothing outside of the grouping symbol, so you just square both sides, and some kids, they automatically forget. What do I do with the square? I write it down twice. 3 times 3 is 9, 2 times 2 is 4, the square root of 4 is 2, so I get 18, and then you're going to reverse the order of operations and take the square root at the end to get rid of the square, okay? So in this problem, I square both sides, but that means I have to box up, right? Because you really have to write this down twice. You box it up, you get x squared, your like term is here, making negative 10, and then plus 25. You move everything to one side instead of equal to 0, and then you factor. Please don't freak out about factoring. I know that you maybe freaked out when you were younger because you thought it was really hard, but it's really about multiplication facts. Like, and first of all, the reason I set it equal to 0 is when you have a quadratic, you must set equal to 0 to solve if there's a middle term. Notice in this one, there was no middle term. I did not have to do that. But if there's a middle term, because you have two variables, you have to set it equal to 0. And so all you do is take 35 and give me multiplication tables. Isn't that 7 times 5? Well, 7 plus 5 is the middle term, 12. And then you just use a little pre-algebra and say to yourself, if I want to get negative 12, it would actually need to be negative 7 and negative 5, because negative times negative is positive, but when I add them, I get 12. And that's all you have to do to factor. But to finish solving this, you then have to set them both equal to 0 and solve each of them independently equal to 0. So the first answer is 7, and the second answer is 5. You have to take the factors and set them equal to 0 to get the answer. All right, and then we get back to a more regular PEMDAS problem. There's nothing outside the grouping symbol, so I inverse the reciprocal exponent. And the reason you do that is if I reciprocate this and get 3 halves, that would give me 6 over 6, and 6 over 6 cancels, right? It just gives me 1. Over here, to evaluate this, you're really jumping back to the front of the paper. What is 4 to the 3 halves? That's literally the front right here. Like, what is 8 to the 3/4? So when I'm looking here, I have to do that same thing I did on the front. That's why we learned it. So the 3 halves power is really the square root. Remember, the 2 is the bottom to the 3rd power. And I could take the square root first, which would be 2, and then cube it, which would be 8. But just don't forget, square rooting in algebra 2 means there's a plus or minus. So if you have a square root, let me show you where the plus or minus comes from. That fraction right there makes the plus or minus, okay? So then once you do that, it becomes just like chapter 1, where you have to set up 2 problems, one for 8 and one for -8, and you solve them and you check them and they both work, put them in order. So over here, please notice that I changed the problem so it would be a little more reasonable. Originally, this was a 4, but then your answers are kind of insane. So change that to a 3 and everything works out. Reciprocate 2/5 to 5/2. All right. Hey, look, there's a 2. That's a square root. That's a plus or minus. Okay, so 5/2 written as a fraction would be the square root of 9 to the 5th, but 9 to the 5th is enormous. So take the square root of 9 first, which is 3, and 3 to the 5th is 243. And again, changing that 4 to a 3 makes those more reasonable. All right, so down here, we have another one that we square, but in this problem, when we square it and we box it up, just like we did in 41, the problem is we still have a radical, right? So we box this up, we have 2 plus square root of x, and we have 2 plus the square root of x. But when I box this up, that gives me 4 plus x plus 4 root x. Kind of like the problems we saw earlier where nothing combined. But when you solve, you can move things. So once you try to get rid of the radical, if you don't get rid of it, get rid of everything it's not a radical, and then square it again. So I subtracted the 4, I subtracted the x. That gave me the x's canceled, and I got 20. I divided by 4, and then if I square again, I get 25 as the answer. So you basically have to square it twice. Almost the exact same thing happens on 45. And then on the last one, number 46, you basically end up in a mess because you do what I said, you move everything over, and then you got to square it again, and then you got to factor, you got to keep going. This is more of a pre-calc problem, but I wanted to show you just what happens. I'm going to make the test stop at 44 and 45. I will not put a 46 on there. But if you can understand that squaring sometimes takes 2 steps, I think that's really where we should be. All right, I hope both these videos were helpful. If you're wondering where the front page is, that is a separate video.